Hello, advanced algebra students, and welcome back to another video as we continue to learn about compound interest and a topic today called APY for some specific financial situations. So, got a lot of different notes and formulas that we're going to throw your way. Pause the video as much as you need to. Make sure you get some of those written down. First, I want to try some true-false warm-up questions with you. Number one, to use an interest rate of 2.4%, you would use R equals 0.24 in the formula. True or false? Hopefully, you said that is false. If we're going to use that as a decimal R, we need to move it backwards 2, which would mean R should have equaled 0.024 in the formula. 0.024. Number two, if interest is compounded monthly, then the N value should equal 12. True or false? If it's compounded monthly, that will give us an N value of 12. This is true. And number three, if your answer from Desmos is 1490.6894 to a certain compound interest question, then your final answer would be 1490.67. Clearly that's false. I even typed it wrong on purpose. We do round to the nearest cent, meaning this 9 makes that 8 change, and we should have had 1490.69. So $1,490.69. So hopefully you found plugging information into the compound interest formula yesterday straightforward. Today we're going to talk about this concept called APY, which stands for Annual Percentage Yield. And what this does is it requires, there's federal regulations that require institutions and companies to post their APY, also called APR, on the account after all compoundings for a single year, have taken place. What this does is it allows consumers to really compare different types of plans. And so we can calculate the APY for certain situations, okay? And there's a unique formula. How much money will you earn in 1 year? APY only covers 1 year, so our T will automatically be 1, which is why you don't see it in the formula up here. Okay. The formula for APY is to calculate our compound interest, that's this part right here, and then take away 1 and change our final answer into a percentage. And we'll go through some examples, but I would make sure you write this formula down to show that it's APY. Again, it's compound interest for 1 year, take away 1. And so when we look at an example, determine the APY of an account paying 5% compounded quarterly, find the interest $1 would earn in the account in 1 year. So my principal, we're starting with $1. My rate is 5% or 0.05. My N value, how many times am I compounding? Quarterly is 4. And again, after 1 year means my T value is 1. So 1 times 1 plus 0.05 divided by the number of compounds, which is 4, all raised to N times T. N times T. 4 times 1 is 4. And then when we get that answer, we're going to take away 1. We will take away 1. So I'm going to have to jump over to Desmos. 5% compounded quarterly. 5% compounded quarterly. 1 times 1 plus 0.05. That's 5% compounded quarterly. And raised to the power of 4. Gives us 1.0509. 1.0509 minus 1 leaves us with 0.0509. Right? So that's the percentage as a decimal. We need to turn this into the percent, that rate, that percentage. So this time we're moving the decimal 2 places to the right to show that we would get a 5.09% APY. Your annual percentage yield would be roughly 5.1 or 5.09%. So we're still calculating the compound interest, and then we're going to take away the value of 1 to see what percentage. We just have to turn it back into the actual percentage. Why don't you pause the video here and see if you can't figure out letter A. What is the APY for 4.5% interest rate compounded semi-annually? Good luck. Okay, this is a continuation off of our last problem. So your principal is still 1. We have a new rate, which is 0.045. Semi-annually means that it's twice a year. So my N is 2. My time is still for 1 year. We're looking at it. APY is always calculated for just 1 year. So we have 1 times 1 plus 0.045 divided by 2, all to the power of 2 times 1, or 2. And then at the end, we will take away the value of 1. So we're going to go back over here to decimals. Let's 0.045 divided by 2 to the power of 2. Take away 1. 0.04551. 0.04551. So if we want to turn that back, that's the decimal, right? That's this R value. We want to figure out the percentage, so we're going to move it backwards over here to get 4.55%. Now, if you don't know where to round to, the directions will tell you, either to the nearest tenth or hundredth, and you can do that on the percentage. All right, let's see what you get for the daily one. Again, P is 1. We have the same R value, but instead of N being 2, the N here changes to 365. Changes to 365. So if I go back to what we had, it's that same percentage, but instead I'm going to divide by 365 and raise it to the power of 365. And you'll notice we get 0.0460. 0.0460, meaning the APY would be 4.6%. Okay, so we can figure out that APY based on compound interest and then taking away 1 and making sure we turn it into a percent. If you got questions, please make sure you let me know. Now we're going to move on. Like, how do we work backwards, right? What happens if I know the ending amount, but I want to know the beginning? Like, how much money would I need to invest right now into an account to have $1 million saved by the year 2050? If I knew the rate and I knew the compound interest, how could I figure out the amount that I need? And so we have 2 ways of solving this. We can use algebra and solve backwards, right? Enter all of our stuff that we know into the formula and then just divide by a lot of that stuff. Or we can use a negative exponent to mark that we're going backwards in time. Okay, so let me show you what that looks like in this example. We're still working out of your packet, but Jordan bought a house on Elm Street in the year 2007. Real estate values are increasing at roughly 0.2% compounded semi-yearly. In 2011, the house was worth $138,000. How much did Jordan buy the house for? So we've got some things here that we are pretty straightforward to enter. The rate is going to be 0.002. The N, how many times is it compounded? Semi-yearly, meaning 2. The years. Well, if he bought the house in 2007, and we're now looking at the house value in 2011, the time that's elapsed has been 4. The question is, how much did Jordan buy the house for? That's that principal, right? This is going to be my question mark. I don't know the principal. I want to know what he bought it for way back when. What I know now is that it's worth $138,000. So that final amount after 4 years is worth $138,000. So we can work backwards here by plugging all of this into our formula. Instead of using A equals, we're going to say that A is really 138,000 equals our principal. We're going to use P because we don't know it, times 1 plus 0.002 all over 2 to the power of 8, right? 2 times 4. And what we can do, if we punched this whole thing, let me put a box around it. If we punched this whole part into Desmos, it would be a number, right? Like, some random number. And so what we end up doing to solve for P is we take the amount, which was $138,000, and we divide it by everything that's over here in that box. That 1 plus 0.002 divided by 2 to the power of 8. And we can punch all of that in to Desmos. So 130, we start with a fraction. 138,000 divided by 1 plus our rate, which was 0.002, divided by 2 to the power of 8. And you can see, I don't know if it'll let me copy that or not. Oh, maybe. You hopefully can see there's the value that we got by using Desmos. Now remember, anytime we're dealing with money, we stop here and we look right after. So $136,900.95 was what he bought his house for. Okay, that's how much he bought his house for. Now that's option 1, where we're finding that. Option 2 is to use a negative exponent. And if I'm going to use a negative exponent, I want to go 4 years back in time, meaning I want to use a negative t. And then my principal represents, what do I have right now? $138,000 right now. So that's our principal. And we're going backwards 4 years in time. So the A value equals our principal times 1 plus 0.002 all over semi-annually, which is 2. But now when I do n times t up here, n times t gives me a negative 8, and we have a negative exponent. Now Desmos will calculate this for us, and it'll still give us a final value, right? 138,000, that's what it's worth now, times 1 plus 0.002 divided by 2, divided by that 2, all to the power of negative 8, because I want to go backwards in time. And you'll see I get the exact same value here that we had from the other problem. So either option is acceptable to use. It's either what's really what's more comfortable for you. All right. I want you to take a moment, pause the video here, and see what you get for number 3. All right. Hopefully it took some time and you found those used one of the 2 different ways. The left-hand side here, I'm using P as the question mark, trying to figure out what did we start with 8 years ago. The right-hand side, I'm going to use principal as $10,000 right now and use time as negative 8 going backwards. So my A value would equal 10,000 times the same thing on the inside, to n times t, which is negative 8. So again, either way is going to give you the same result. So 10,000 at 7%. So 10,000 at 7% compounded annually, meaning it's just once a year, to the power of -8, because I want to go backwards in time, and we get $5,820.09. $5,820.09. So again, we're still using the compound interest formula. We're just trying to figure out what did we start with by working backwards. If you have any questions, please make sure that you do indeed reach out and let me know. Keep working strong as the fourth quarter starts. Otherwise, until next time, everyone, stay safe.